Hey guys, welcome to today's video. In this video we are going to solve a classic low level design question, which is designing a parking lot system. So without further delay, let's get started. So whenever interviewer asks for a low level design question, so the thing which interviewer is looking for is your understanding of object oriented principles, your design pattern skills, your knowledge on thread safety, concurrency, data modeling, and how clean is your code, like what are the principles you are following, like are you able to do separation of concerns, modularity, scalability, etc. So so to start solving this question, first we need to understand the requirements. Yes, you will get only this part, designing a parking lot system, but there is a lot more behind it that you need to solve it. You need to understand like what exactly interviewer is looking for, because different interviewer are looking for different things from a system. Suppose if you're designing a parking lot, somebody wants that how you are calculating the price of the ticket. So some interviewer want to dig deep into that, or someone wants like how you are booking the slots, like how you are checking like whether your parking is available or not. So they are more concentrated on that zone. So you need to understand their requirement, what exactly they are looking for. So for this you need to have a good communication skills. So you need to keep asking them what exactly they are looking for. So before jumping into design, clarify the functional and the non-functional requirements very clearly. Okay, so for this parking lot system, suppose the functional requirements we are looking for is, first we need to jot down which is the very basic one for a parking lot. Okay, we can, and if interviewer wants, we can build on top of it any requirements they are looking for. If you have not yet listed it but still they are looking for, then you can ask them. Okay, so the basic ones which I can think of is like parking and unparking, right? These are like I think that a parking lot system must do these two functionality, right? Now we should my on top of my mind is something like, if you are parking, we'll always park a vehicles, right? And vehicles can be of any type. Even if it's two type you will solve, but it can have multiple types of vehicles, right? So we can write support multiple vehicles, right? For example, car, bike, truck, etc. Okay, now we need to have available slots for that, right? So we need to track available spots, right, per vehicle. Like it totally depends on the type of vehicle you want to park, right? You cannot park a car in bike parking, correct? So you need to track the available spot as per your vehicle type, as per vehicle type. If a parking spot have multiple floors, okay, so it can have two floors for parking. I think it's a bit corner case, but I think it is like will not always happen nowadays. Will not have one floor of parking, so we can add this. And if you can always talk to the interviewer if they are looking for this, or we can remove this particular requirement, right? So handle multiple floors, okay, floors or levels, whatever you can call it, right? Now for you need to have a payment system, right? Payment and ticketing system, right? Now so let's I think we have covered a very basic parking lot system requirements, but it can be many things, right? You can add like multiple gates for this parking and unparking. There can be multiple gates. Then you can add like a real-time camera integration. So there are a lot of requirements, so there is no end to it. So you need to cut down the requirements, and you need to ask, even if you cut down like out of, you had 10 requirements, you got down to 6, still you need to ask the interviewer that you need to, and you want the implementation of all the things, or we can cut down even that, because you need to do everything in a appointed time, right? So for our need, we will solve these functional requirements. Now, after jotting down the requirement, second thing that you need to do is to write the core entities and the classes. So obviously when we start reading the object oriented programming, the very basic thing what we learn, so all the nouns and the verbs we can get, right? So in a similar fashion, you can just jot down all the core entities and the classes. Okay, identify core entities and classes. Okay, so what I can see, like from this itself, we can say a parking lot, right? Then a parking floor, right? Parking spot, ticket, so vehicle type. What more we can think of? Payment, so is there anything else which we can see? I think this is enough, and if we always need some more classes, we can add during the designing part. So for as a high level, these entities should be enough, right? Now the third thing is, right, you need to have a class design. Okay, so you can write pseudo code, or you can design an overall picture of the classes and its relationship, and then we can deep dive into like what exactly we need to do. Okay, so to do that, we can start from the very basic. Okay, design. So we can start with vehicle type. Okay, so it can be car, bike, truck, so you can add whatever you want. Okay, now vehicle, so vehicle will always have a registration number, right? And what more? Yeah, vehicle type. So vehicle will be comprises of these two things, right? And you can add constructor. Okay, now you can add something, parking spot. It will have an ID, right? Vehicle type, we can name it as a spot type, and if it is available or not. Right, you can create constructor for this also. You can add string ID and vehicle type. Okay, so in the constructor we can initialize something like this. this dot is available as true. Okay, now moving on, we can create a ticket type. So these are some of the main entities. We can add a ticket number, that is first, vehicle, parking spot, entry time, exit time, and fee. Right, we can add constructor for that also. Right, so we need here ticket number, vehicle, and parking spot. Okay, so we can add this dot ticket number equal to ticket number, this dot vehicle is equal to vehicle, this dot spot equal to spot, and this dot entry time will be the current time. So whenever you are creating the ticket, at that point of time is the entry time, and these two things will be calculated later. Right, now we have something called parking floor. It will have some kind of floor number, right, and list of parking spots. Okay, because each floor will have the parking spot and all the floors will make a parking lot. Okay, so you can name it as spots, and you can add a constructor for this also. So it will have int num and the list of parking spot, this dot floor num equal to num, and this dot spots this dot spots equal to spots. Okay, now we come to our main class, which is the parking lot. Right, so what it will have, it will have a list of parking floor. You can name it as floors. Right, and we can add a map of ticket number. So our ticket number is string and ticket, so all the active tickets will be here. Okay, so I can just add a comment here. So it is ticket number and ticket. Okay, so we can add constructor for this also. So we need list of parking floor. So our this dot floors is equal to floor, correct, and this dot ticket will be initialized with new hash map. Okay, now our parking lot class will have a public method which will return me the ticket. Okay, whenever we are parking the vehicle, so we will get the ticket. So we need an input as vehicle, right, and we will return the ticket for that, right? So this is one functionality. Second is unparking. So just imagine, for unparking, what you need in return? Nothing, right? So if unparking is the functionality, okay, if unparking is the functionality, then we need, sorry, only ticket number. So that is enough, right? So these are the two main functionality, and one functionality which is internal to the system, so that's why I will make it as private, is calculating the fee. So it will take the vehicle type, and the duration. So these two things should be enough to calculate the fees. We don't need the ticket number, we don't need the type, the vehicle number. These all things are not required for calculating this data. So let's start with the simple one. So now how do we calculate? So this duration we will take in milliseconds. Okay, so what we will do, we'll calculate hours, so which is like duration milliseconds. We will convert it to hours because it will be much simpler to calculate. It is on the per hour basis we will calculate. Okay, so we'll divide it by 1000 into 60 into 60 plus 1. So even if it is lesser than an hour, we will charge for 1 hour. Okay, now we need to add a switch case of the vehicle type. Okay, so if my vehicle type is car, okay, suppose, then we will return hours into 10, something of that sort. And if my vehicle is bike, then I'll return hours into 5. And in case of, like, we use 3 things, right? Truck, we can return hours into 15, and for rest of them, like as a default case, we can return hours into 10, whatever you want. So our one functionality of calculating the fees is done, right? Now to park the vehicle. Okay, so for parking the vehicle we need an available slot, right? And then so what we will do, for each, because we have parking floor, right, floor of floors, so we already have the floors, right? For each floor we will try to find our parking spot. So each floor will are having the list of spots, right? Spot, it is like floor dot spots. Okay, now we'll check if the spot is available. Okay, and our spot dot vehicle type, no, spot dot spot type is equal to our vehicle dot type, right? So if both matches, then we have that available slot, right? So in that spot what we will do now, it's available equal to false, we'll mark it as false. Now we will create a ticket ID. Okay, it is a new ticket ID. Suppose you are generating via UUID. Okay, random UUID. Okay, dot to string. Okay, we have generated a unique ticket ID. Now we will create the ticket. Okay, equal to new of ticket, and we will what exactly our ticket need is ticket number, vehicle, and spot. Okay, so our ticket number is the ticket ID, vehicle is it, we already have the vehicle and the available spot. Okay, now we will keep this tickets in our map. We will put the ticket ID and the ticket. Okay, now, and we can return this ticket. Okay, and if we do not return anything, then we can throw the exception, new run time exception, that no spot is available for vehicle type, vehicle dot type. Okay, so our parking of the floor is also done. Now we need to do the unparking, right? So unparking, we need only ticket, so we need to get this ticket out of our map. So we have a hash map of ticket number and tickets. So what we will do, in from the tickets dot get of ticket number. Okay, now we got the ticket object. If our ticket is null, then we need to throw an exception, throw new runtime exception, invalid ticket number or ID. Correct. So now we need to add exit time in our ticket, which is the current date, right? And so we will calculate the duration, right? So which is ticket dot exit time dot get time, because we'll need that in milliseconds, minus ticket dot entry time get time. So if you see over here, I am directly accessing these fields, exit time, entry time, but we should always use the getter and setters for that. So these things either you can say, or you don't have to mention every getter and setter. You can just mark something like this. So suppose you have a ticket, you can always do something like getters and setters. Or if for any case you don't want to have a getter and setter, then you can explicitly mention only those fields, because we don't want to spend any more time which is not very productive, or which is not giving any value, which is not adding any value to my interview. Okay, so I got the duration. Now I need to get ticket dot fee, which is like calculate fee. We will call the calculate fee method, and we will send the vehicle type. So I have this in my ticket, so ticket dot vehicle dot type. So we got the type also, we have the duration, right? Now you can use this out for now. Vehicle parked, vehicle unparked fee, is, and you can add a colon as ticket dot fee. Okay, so I think we have covered all the main functionalities which we have asked for, right? So you can see uh, parking unparking functionality, this is done. So we have support for multiple vehicles type, correct? Now we can track available spot based on the vehicle type. We have handled multiple floors and levels. We have payment, it's a very basic one, but we have the payment and the ticketing system as well. So we have covered all the major functionalities which we have picked up in the starting, right? So now after that, we need to make sure that while we are designing these things, we need to be make sure that we are using a proper design patterns, proper design principles, solid, dry, everything you need to use in that particular thing. And especially for that classes which your interviewer is saying to elaborate more on that, right? So like for calculating the parking fees, we have used the strategy pattern, even though it's very basic, but we have used the strategy pattern over here. Then for creating the different types of spots for tickets, we have used the factory pattern. So you need to make sure you are very confident in what you have designed, and you are able to give the explanation of your thought process, like what you have thought, what is your thought behind it, why you have chosen a particular data type or a particular data structure, what was the need of it. And if you want, suppose if there is a ticket id, I'm just giving you a brief example over here. Suppose ticket id, it can be a string also, it can be a uuid also, it can be a number also. But if you have chosen string out of these three, then why you have chosen it? So you need to have a justification for your choices, and you need to basically you have to justify your things what you are writing, so that candidate, so that interviewer will come to know that yes, you are knowledgeable in that domain, but you have knowledge of all the things, but you have chosen in one of them. And this is since that was the thought process behind it, so he'll also be satisfied about your explanation, right? So after this, after designing this, you can definitely ask your interviewer, is it enough, or you want any further more explanation, or if any more elaborate design on any particular class or entity or functionality. Okay, hope you understood the steps to go through for the low level design using this example. And if you want me to create any more examples like this, just comment down below. Thanks. See you in the next video.